Assalamualaikum. Today we from Group 1 BNT will give a presentation on the case study that resulted from the bridge collapse in Zhejiang City, China. So, this is my group member. First is Muhammad Nuraiman bin Muhammad Tajuddin. His number matrix is CN230180. Next is Damia Farwiza binti Azman and the number matrix is CN230303. And the last is me, Muhammad Danish bin Nazaruddin, and my number matrix is DN230020. So, let's talk about the introduction of bridge construction. Bridge construction is essential for enabling safe passage over obstacles. It requires meticulous planning, engineering, and construction. Recent bridge collapse emphasize the need for careful construction. There are the major issues included in this project. The first one is excessive load causing deformation or collapse. The second one is lack of adequate support materials leading to unsafe structures. And the third one is incompatible construction materials compromising structural integrity. However, next is three main objectives in this project. The first objective is to analyze the force and moment based on the FBD. The second objective is to identify the problem causes of the bridge collapse. And lastly, the third one is to suggest new solution for solving the problem of bridge collapse.
So now it's my turn to present about the project theory. So the first one is what is bridge. Every nation needs the infrastructure to perform all kinds of activities related to the improvement and service of the society. Transportation system became part of the infrastructure due its connection between two destinations using maritime, land or aerial method, creating a link for social and economic activity. Bridges are widely used to cross river, valley and roads, providing a passage with other parts of the land since ancient times to modernity, based on Arturo Gonzalez 2018. Other than that, every nation needs the infrastructure to perform all kinds of activities related to the improvement and service of the society. Transportation system became part of the infrastructure due its connection between two destinations. So next, I will talk about the commonly used bridge structure. A truss is a unique type of structure known for its high strength to weight and stiffness to weight ratio. This structure form has been used by designers for centuries in a wide range of applications, including bridges, raised car frame, and the International Space Station based on Philip Koski 2021. Trusses are structural systems made up of bars. Truss member cannot tolerate bending edges, and the nodes provide stability for the members on the truss plate. How the truss members are connected to each other or how the truss is connected to the welding machine is through the bolt and rivet. It is completed or connected to the truss member using bolt and nut. These connections are just as important as the rest of the truss member because they can significantly reduce the risk of truss damage caused by improper welding or bolting, based on Muhammad Zamani 2021. For this project, we use method of section to get all the value of the unknowns. So this is the figure 2 of 2D free body diagram of bridge collapse. We identify the problem of collapse bridge by using the 2D free body diagram FBD. The 2D FBD simplified represent the problem of the object or structure. So based on figure 2, the 2D FBD shows the red line has received a critical pressure caused by the overload and causes collapse of the bridge. Next, to avoid or reduce the problem, we decided to create a new design, namely truss bridge.
Next is for figure 3, 3D FBD of truss bridge. We sketched and chose this design because the truss bridge is the most effective design. The truss bridge has tension and compression elements, which is when under gravity loads. The top and bottom charts of the truss provide compression and tension resistance to overall the bending and resist the shear force.
For the parameter and calculation, we are using the section method for calculate the reaction member of force bridge. The force given is 94144 Newton. We start to calculate the equation, which is AY plus GY minus 94144 equal to 0. So the value of AY is 47072 Newton. However, the value of GY is equal with AY. So the value of GY is 47072 Newton. Next, we have to calculate the sum of MJ equal to 0. The equation is FDE times 0.3 minus 47072 times 0.3. So the value is 47072. While the value is positive, so is a tension. Next, we started to calculate the joint A. First, we need to find the edge of length, the horizontal line of bridge. So 16 cm divided of 6. The value is 10 cm. Convert to meter is 0.1 meter. To find the L, we use theorem Pythagoras. So square root of 0.3 square of 2 plus 0.1 square of 2. We get 0.32 meter. Next, we calculate the Fy, which is FEL. So the FEL we get is negative 50077 Newton. While the value is negative, so is compression. Next, we calculate the Fx, which is FAB. The Fx we get is 15523.87 Newton. So is tension.
Next is we must find the value at joint B. First thing first is we need to calculate the sum of Fx between FAB and FBC. So FAB plus FBC equal to 0. Then we substitute the value of FAB, which is 15523.87 plus FAC equal to 0. Then we bring the value of FAB to the behind. We get FAC equal to minus 15523.87 Newton. And that is the compression for joint B. Next is we must to calculate the value at joint L to get a value of FLC. So we start off the sum of Fy equal to 0. So the equation is minus FLA in bracket 0.3 over with 0.32 equal to 0. Then we settle it with the bracket. First in the equation, which is negative FLA in bracket 0.94 minus FLB minus FLC in bracket 0.94 equal to 0. Then my negative 0.94 times the value that we have substitute if FLA, which is negative 50077 Newton minus to 0 minus to 0.94 FLC equal to 0. Then we bring FLC to the front and the constant value to the behind. Then we have calculate, we get 47072.38 divide to 0.94. Then we get the value of FLC is 50077 Newton, which is tension. Next is we calculate for Fx. The equation is negative FLA in bracket 0.1 over 0.32 plus FLC in bracket 0.1 over 0.32 plus 2 FLK 0 equal to 0. Then we get negative in bracket minus 50077 times with 0.31 plus FLK equal to 0. We get the value, which is 1552.87 and 1550 23.87 plus FLK equal to 0. Then we use the same concept as we said before, which is FLK equal to negative 155023.87 minus to 155023.87 we get is
Next, we start with joint C. So we have to calculate the Fy, which is FCJ. So the FCJ we get is negative 576.60, while the value is negative, so 576.06 is compression. Next, we have to calculate Fs, which is FCD, and the value is 155.23.87, while the value is positive, so it is tension. So next we start with joint J. We have to calculate the Fy of joint J, which is FJE, and the value is negative 50209.78, and it is compression. And the Fx, which is FJI value, is negative 310,006.12, and it is compression. So we can summarize: the compression and tension value that we get from the calculation allow us to evaluate the stability and integrity towards the system of truss bridge that can minimize the risk of KF failure of bridge. That's all from me.
Solution for solving the problem. It can be demonstrated that this truss bridge is an effective way to address the issues that arise in Zhejiang City based on the calculation and design that have been selected. The truss bridge strength and extended lifespan are attributed to its ability to withstand enormous loads and harsh weather conditions, primarily relying on tension and compression as structural elements. In addition, the truss offers an excellent balance between cost, span, strength, and weight. After completing this case study, we learned the stability of a bridge is largely dependent on its parts. Bridge selection is crucial in ensuring that bridge can support the weight of passing cars, trains, and people. Since we decided to use a truss bridge to tackle the issue, we came to the conclusion that trusses are used in bridges that are more complicated than their basic beam counterparts. A truss bridge is a suspension bridge with structural support provided by a web of beams. A bridge strength is increased by its truss design, which uniformly distributes weight throughout the structure. The bridge trusses prevent the weight of the cars and heavy goods from causing the structure to collapse. As a result, truss bridge construction and the geometric properties of triangle give them an incredible capacity to support loads. A truss bridge can control both compression and strain equally well because of the force that is distributed outward from the road. A truss bridge has a far longer lifespan than a beam or arch bridge. They are the preferred building technique in dangerous areas like the valleys that separated mountain peaks because